Hi everyone, my name's Keith from CID Garden Rooms. Today we're going to be showing a video on how our garden rooms are constructed. This example is for a timber base, so we basically start off by digging some holes in the ground. They're going to be 40 centimetres by 40 centimetres by approximately 50 centimetres deep. It will depend on the ground makeup where you are. Not all ground makeups are suitable for this design, so it's imperative this process goes correctly to ensure that you have a garden room that's going to last many years. These pads are normally about 1.2 to 1.5 meters apart. We normally put 3 rows in. That will cover us up to garden room depths of 3.6 meters. If we went beyond this, we'd need to put an extra row in. So we've got our holes all dug in here. From there, we put a base pad in. So basically, these are designed to keep your timber floor off the ground. Timber framing largely uses treated C24 grade timbers. It's class 2 timbers, so it's not designed to be used in direct contact with the ground. So if you want your garden room to last a long time, you need to keep a good 50mm air gap underneath to prevent the timbers getting in contact with excessive moisture. From here, once all that's in and level and happy, we build some floor joists in for you. And as you can see here, we have got a double trimmer at the front and the back. That is to support the walls. If we only had one timber there, then it's going to allow too much movement in the wall timbers. On the sides we've got a triple. Again, we've got a double to allow your wall to sit on, and then we've got another timber which later will support your floorboards. On the ends, they're all screwed through from both ends, and they are then kept in place using joist hangers. So they're kind of belt and braces to hold it all together. Floor is probably the most important part to get right, because the last thing you want to have is a garden room that lasts but the base starts to fall away over time. So this is a good proven method to keep your garden room off the ground and stable. Once we've got your floor timbers in, we will put some insulation. We use 50mm PIR insulation. That's similar to Celotex and other brands like it. So what we do to stop that Celotex falling all the way to the floor, if there's any expansion and contraction of the timbers, is we put a 50mm roofing batten along the bottom edge of the joists, and then the insulation just goes down and sits on top of that. You want to make sure, obviously, all these are nice and tight when they go in. Any air gaps where cold air can be sucked into the building is going to risk water vapour forming and then rotting out the bottom of your garden room. So you want to make sure it's nice and tight. Any gaps can be filled with expanding foam. Once all this is in, we then insulation tape. So it's a foil tape. We tape up all the joints, overlapping all of it. One, it helps reduce thermal bridging on the timbers by reflecting heat back into the room, and also eliminates any risk of air getting into the build. On top of this, we installed 22mm caber flooring. Now our studs are at 600 centres, unless there's heavy equipment going in. So 22mm gives you a nice solid floor. All of it's glued and screwed down to the joists, so there's no chance of that moving. Nice, strong, stable floor. We then start with wall timbers. So the wall timbers, we use a 4x2 stud frame, and as you can see here, it's going to be quite strong. We've got all these timbers at the front here, and there's a reason for that. We've got our lintel up here, and we need to ensure that our lintel is properly supported. We have 2 timbers underneath it, so that gives us 94 millimeters of bearing space to transfer the load of the roof that's going to be pushing on this top plate down onto your wall studs. We put an extra one in here. That's simply to so we can fix the lintel through to these and help tie all that together. On the corners you want a double trimmer here, and then that will allow this wall stud to be fixed straight through to that. These windows are 1.2 meters wide, and the French doors will be 1.4 meters wide. For this, our calculation came back with a 5x2 or a 47 by 120 millimeter lintel. That is doubled up, and they have to be bolted together to ensure they act as one. We then have a top plate. This holds everything together. It also helps distribute the weight of the roof evenly down throughout all the studs, and the same reason for the back. We've got a double trimmer at the top, so if you've got a ceiling joist, roof joist in the middle of that, it's going to help transfer that load across to your upright studs. And that's basically your studs. The only thing we've not drawn in yet is our centre noggins, and that's to help tie all the walls together and stop any bow or twisting as the wood settles over time. Okay, so once we've got all our wall studs in, we're going to install OSB sheathing. So this is Orient strand board, sometimes called Sterling board. We use 11mm thick boarding, and the whole idea of this process is to strengthen the walls. At the moment, as it was without the sheathing on, you would have a risk of buckling and twisting. Sometimes under wind force, you've only got to look at an old shed. And when you look at an old shed, it's no longer upright, it's all twisted and buckled. And the whole idea of this OSB sheathing is to stiffen up the frame, make sure that it can't move. Okay, we nail this every 12 inches onto all of the studs, and that then holds it nice and solid. We then install roof timbers. So as you can see up here, we've got all our roof timbers in. We always put this perimeter timber on, and there are 2 reasons for this. One, as it's fixed through here, it prevents the ends of these timbers from twisting over time. Okay, and that is the very same reason you have to put these noggins in the middle as well. It's just to help stop those timbers from moving over time, because they can twist and buckle. You know, wood is a natural product, so it will move over time, and the idea is to prevent that movement, so then it's forced to set in a particular way. We've got our noggins coming across here for our overhang. We normally do a 300mm overhang, and there's a reason for this. When rain is coming down, you want the roof to take the burden of the rain. The more water you have going on your cladding that will be on the outside of this garden room, the greater the risk of it rotting. So you want to make sure that this overhang just prevents, you know, as much water as possible from hitting the cladding. It also helps prevent a little bit of splash up from the ground as well. So all these timbers are in. We use upside down joist hangers across here to tie them into the top rails of the garden room. This will hold all your roof in place. It'll be nice and rigid, it's not going to move anywhere, and it also helps uplift from wind. So when the wind comes in and it blows under here, there's a risk of roof movement unless you fix it down sufficiently. Right, so once we've got all those items in place, we then look to put the OSB lower deck on. So again, similar reasons for the walls. This sheathing will help stiffen up the roof structure. We use 11mm OSB to help reduce the thickness or the profile of the building to give you as much headroom inside as possible. Once all this is screwed down, we then want to install a parapet. So this is a 4x2 parapet that goes all the way around the garden room. From here, this will help stop the insulation coming out. It will give you a nice solid surface like below for your fascias to nail onto, and also for your EPDM trim covers and for the top deck that will go on in a second. So this is an example of a warm deck roof that we do more often than not because it's more thermally efficient, it's less prone to issues, so it's just the best method. The losses, you lose about 4 inches of height on the inside of the room, but with our garden rooms we still manage to maintain about 7 foot of headroom, and we think it's a reasonable offset to have a better quality, more thermally efficient roof. From here we install a self-adhesive vapour barrier. So the idea of a warm roof is if there's any risk of moisture getting into the roof, we don't want it to penetrate the build. So this is a self-adhesive vapour barrier. You can use a primer with it, which will make it stick even more. We tend to find that we don't need it because we're going to use mechanical fixings for the top layer of EPDM, for the top layer of OSB, sorry. So we're not too bothered. As long as it's stuck down to the OSB relatively well and it's sealed to itself, that's all we really need it to do. Some people will use a polythene type vapour barrier for this. They're not as suitable, they're nowhere near as good as this self-adhesive membrane. When you screw through this, it seals better around the screws than what a plastic would do, basically. So there's less risk of failure. It works out to about £7 to £10 a square metre more expensive on the roof, but by far a better method of doing a warm deck roof. From here we put 100mm PIR insulation into the roof. You want to make sure all of this is nice and tight. You don't want any trapped air in there because trapped air will hold moisture. Moisture will condensate and evaporate as the building heats up and cools down several times a day. So nice and tight. You know, get a hammer and block and you want to knock all these sheets in so they're nice and tight. As with the floor, we want to tape all of our joints. Okay, so once all these are taped up and looking good, we then put our upper deck of OSB on. Now you can glue EPDM rubber straight to your insulation, but for the sake of 11mm and the cost of what OSB is, it's not really worth it. This will give you a much better quality roof deck. Now, as before, we said we use a mechanical fixings. So along our parapet edge, we will nail that with 50mm Paslode nails, approximately every 200mm or 10 inches, and that will get all nailed down. In the middle, we will follow where the joists are, and we use very long screws. We use 170mm long screws. That ensures we get about 50mm into our joists underneath to hold that nice and tight. It's a really tight sandwich between the 2 layers of OSB and the insulation. So any air that might have been trapped in there is just forced out when it's all screwed down nice and tight. So we've got our walls, we've got our roof. Now we want to see about starting to make this waterproof so we can start working on the rest of the build. So we're going to go around and we're going to put our fascia boards on. Okay, it's going to finish flush with the top here. there is a good chance you're going to have to trim the boards down to the correct height. It's so rare that you'll be able to buy a board that will fit the thickness of your roof. You normally have to buy one size bigger and just rip them down with a circular saw, or use a sharp handsaw. Either way, you know, just trim them down, nice tight fit on there. We then lay our EPDM rubber on the roof, and you're going to want to leave that EPDM rubber for maybe an hour, 2 hours, maybe longer in the winter months to let all the creases where it's been stored fall out. If you get most of your creases out now, it's going to save you a bit of hassle when you come to glue it down. Okay, so once all the EPDM has been glued down, it's going to overhang the edges by about 50 to 60 millimeters. We're then going to install our EPDM trims that go on, and the trims just trap the rubber between the fascia board and the trim. They've got a gasket seal on them, which then seals the roof. You will have curb trim around all your raised edges, and then you'll have a gutter trim, which normally comes in 2 parts along the back. And then you've got a nice waterproof room that you can continue to work in. That's the end of the first video. Hopefully you found it informative. If you've got any questions, please leave a comment below and we will try and respond to you as quickly as possible. Thank you very much.